Good morning, Doctor. I'm Lio Yi Kee, matrix number 253068. Today, I would like to present about the findings of my research, which is the application of integer linear programming for optimization in housing development project. I would like to start off by giving an abstract of this research. This research focuses on the application of linear programming for optimizing the cost of a housing development project in Bandar Lapas, Pulau Pinang. The project duration is set to completion in 72 months, where a total of 169 units of houses will be built, consisting of 4 different types of units. The project will be distributed among 3 different contractors, and the pollution compliancy are set in accordance with the environmental aspect. The result of the integer linear programming depicted that as much as 42.13 million ringgit is needed to complete the entire project, while satisfying all the given constraints. Construction of the model is executed using Microsoft Excel solver, and the steps are explained in this study. First part of this presentation will be introduction. To give you an overview of this study, in this era where population are booming, resources are getting more and more scarce, and people need to be more aware of everything that they are doing as waste and pollution are growing in an intensifying rate. If resources are infinite, then there is no need for the existence of linear programming, as everyone is able to harvest and excavate everything for its own good. However, due to the nature of the earth, resource is limited, and there are ample of evidence out there that suggests climate change as one of the biggest threats of mankind in decades to come. Therefore, by optimizing resource allocations, we are able to minimize the amount of damage done to the nature, hence preserving it for future generations. Constructions have been one of the biggest sectors since the age of industrialization, and unsurprisingly, there have been many cases of overruns in this sector, which involves elongated delays, additional costs in millions of ringgits on labor and resources. Hence, this research aims to develop a mathematical model that can minimize the construction cost and time which involves pollution compliancy and deadlines in a housing development project. The main objective of this research is to formulate a mathematical model for housing development project case study under the given constraints. Meanwhile, 3 subsequent objectives of this research are to determine the feasibility of the housing development project under initiated project duration. Secondly, to determine the minimum cost needed to complete the project. And third, to divide the construction project among contractors under several constraints. This research will redound to the benefit of society, considering that linear programming plays an important role in many kinds of optimization problems. The application of integer linear programming in construction will not only reduce time and cost, but indirectly reduces waste and damage to the nature. Moreover, authorities of development projects can make better decisions when it comes to resource optimization. For the researchers, this study will hopefully be a stepping stone for them to understand the real-world application of linear programming and to make further improvements on it. We'll talk about the second part, which is the research methodology. The problem originated from a case study where there was a problem dividing construction jobs among 3 different contractors in order to speed up the time of completion of the housing development project. Each contractor is different in terms of its capacity, such as the size of the team, projected time of construction for each house, as well as the cost for each type of houses. The goal is to determine the minimum cost needed to complete the project under several constraints. Integer linear programming is the main mathematical model that will be applied to this problem. In order to achieve the research objective, Microsoft Excel solver will be used in order to carry out the optimization. Let's have a look at the overview of the plan. This research adopts a secondary data collection approach. To formulate the problem mentioned above, the data collected comprises of construction cost, construction time, construction dust for each type of houses with its construction method given by contractors, as well as project duration. Next, we come to our mathematical model formulation part. The mathematical model for this research is made up of three main parts, which consist of decision variables, coefficients, as well as objective function. If we look closely to objective function, we can see that the main objective of this research is minimization, and there are 10 constraints which is associated with it, and which includes the type of houses, project duration, as well as the complexity of construction tasks. First of all, we'll run the model in a basic. In the basic model, only construction time was taken into account, where the main purpose was to allocate the number of houses to be built among different contractors within the given time, which is 72 months. With Excel Solver, we are able to obtain the optimal number of houses to be distributed among three contractors with the minimum cost by setting up the objective cell, changing variable cells, as well as subjecting the constraints. You can have a look at the solver parameter figure. The result shows that the total cost of the project will require around 41.89 million ringgit to complete. Next, in the findings of the basic model, only construction time is taken into account. However, in real-world application, there should be other factors that are equally as important, as the predefined constraints suggest. Dust pollution as a constraint is appended in order to force contractors to comply with the pollution policy. In this model, the total construction dust produced by each contractor should not exceed 10 throughout the entire construction of the project. Likewise, Microsoft Excel will be used to run the model analysis. In this scenario, three equations is added into the basic model to form the basis of scenario 1. Figure above shows that the result from the application of integer linear programming through the use of Excel Solver. The result shows the minimum cost and distribution of project among contractors after factoring compliancy of dust pollution into account. The total cost of the project was found to be as much as 42.13 million ringgit, which is up by 245 ringgit from the basic model. Next, we come to our conclusion. The results obtained have proven that the application of integer linear programming is applicable to construction problems in terms of cost optimization. By using this model, a construction manager or project lead will be able to determine the optimal solution from the cost aspect. Future research from this study should include more constraints or be applied to a more complex problem. Moreover, the fundamental idea of this research should be extended to encompass different objective functions such as minimizing project duration or maximizing project's profit. That is all from my presentation. Thank you.